Six Sigma is a data-based approach for problem solving. So frequently we are talking about data. So first let us try to understand what is the definition of data. So data is organized information, right? So all of us are having tons and tons of data in Excel sheets and PowerPoint presentations and the Word document. So tons and tons of data we have. So the data is actually an organized information. So it can be in any form, because typically when we talk about data, immediately what comes to our mind is data means only numbers. But that is not the fact. Data can be in any format. So data can be in numbers or words or measurements or observations or even just description of items. Right? So for example, let us assume that uh, a particular person was running a school. So he wanted to give a Diwali gift to the students who are studying in his school. So he wanted to give different gifts for students who are studying in different classes. So in order to calculate how many number of gifts in each category he has to buy, so he needed data. So he just asked his people to collect the data on the class type, which class, and the number of students. So there we were having class 9, 10, 11, and 12. And in class 9, around 72 students were there. Class 10, 82 students were there. Class 11, 77. And class 12, 16. So once he has the data on the number of students who is studying in each class, then he'll be able to immediately calculate the number of gifts he has to buy in each time. Right? So without this data, he would not have been able to take that decision. Right? So the data is always collected in order to get some information. Based on the information, we'll be able to take the decision. So that is the purpose of collecting the data. Right? So data should lead us to information, and based on the information, we are going to take some decision. So database decisions will always be accurate, and then that will give us a good ROI, return of investment. So the data can be broadly classified into two categories, that is qualitative data and quantitative data. Quantitative data is also called as numerical data because it is always in numerical format. So we also call this a numerical data. And quantitative data again can be broadly classified into two categories, that is discrete data and continuous data. So discrete data is also called as the attribute data. Is also called as attribute data. And it is the outcome of a counting process. So in the example, whatever we were seeing just now, when we are wanting to get the data on the number of students in each class, then we are getting the numbers as 72, 82, 77, etc. So since these numbers are outcome of a counting process, then we can say this is a discrete data. Right? Discrete data is an outcome of a counting process. So the discrete data can take any values, any whole number values. From 0 to infinity. So no negative numbers, no fractions, no decimal. So only distinct values 0, 1, 2, 3, 4 up to infinity. It can take any value, right? So that is about the discrete data. This is the outcome of the counting process. Continuous data is also called as the variable data. That is the outcome of a measurement process. So whenever you are measuring, like for example, you may be measuring some dimensions, you may be measuring some temperature, pressure, time, viscosity, velocity, um, hardness, inductance, resistance, etc. So whenever we are measuring something and then we are noting down the value, then we call that as a continuous data. It is the outcome of a measurement process. So the uh, continuous data can take any value from minus infinity to plus infinity. Any value from minus infinity to plus infinity. So all decimals and fractions included, right? We can take any value from minus plus. The quality data can again be classified into three major categories. That is the nominal data, ordinal data, and binary data. So nominal data is the description of items. So for example, the name of the colors, the name of the smells, the name of the cities, the name of the countries, the names of the sales region. So even in this example, whatever you see, the name of the classes, the description of the classes. So these are all examples of nominal data. So we are describing some items. So we call this the nominal data. Right? Ordinal data is a outcome of a ranking process. It is the outcome of a ranking process. So, for example, we like to divide the people according to the income group, and then we may say that it is a low income group, medium income, high income group, or BP, low BP, moderate BP, high BP, and so on. Or suppose if I'm just asking you to give a feedback about my training in the scale 1 to 10, 1 means very poor and 10 means excellent. Then you are going to give some rating, like maybe 7 or 8 or 9 or 10, whatever it is. So that number rating, whatever we are going to give, so that is also a ordinal data because it is the outcome of a ranking process. Binary data is a outcome of a process having is the outcome of a process having only two possible results, yes or no, pass or fail data type. So whenever you have a process which has only two possible results, that outcome we can call that as a binary data. So these are the different data types, and understanding the data type is very important because it is one of the major criteria for selecting the appropriate statistical tools during any phase of the 60-month process. So under the same conditions, maybe different statistical tools can be applied, and exactly which statistical tool you have to select in order to make that selection. One of the major criteria, I won't say this is the only criteria, but one of the major criteria for selecting the right statistical tool is the data type. So that is why understanding the data type is very important. Maybe I can write it so that it's very important. Understanding the data type is very important. Since it is one of the major criteria for selecting the right statistical tool. In any phase of a Six Sigma project. So as we are proceeding further, then you will be able to get a clear idea where every time I will be referring to the data.